For this one here, we have the quadratic function. We just have a point, so let's just quickly sketch this. I do want to know where the vertex is. So I'm just going to quickly solve for p. So p is equal to negative of -4 over 2 times 2. So I'm going to get p value of 1. So if p is 1, actually, why don't we actually solve for the vertex too? If I know the p value, if I know the x-coordinate of the vertex, I plug in 1, I get 2 minus 4 plus 3. So the vertex is going to be at 1 and 1. So there's my vertex. And I have, it's going to go something like that. A y-intercept of 3. And m and n is some point on that parabola. Now, where do I draw it then? Well, essentially I can draw it anywhere I want. So I'm just going to draw it in a convenient spot here. I'm just going to say that m and n. And what am I looking for? I'm looking for this coordinate here, which I'll call x and n. Okay, and we know that that point must be symmetrical across x equals 1. So how do I find the location of this coordinate when I don't even know the numbers for this? Well, this is what I meant about generalization. We want to start generalizing this in terms of its relationship. And so we're not calculating. We want to know what is the relationship we need to use to understand the location of this x coordinate. And it's this idea of symmetry across that middle. So I'm going to use the average formula. So m plus x divided by 2 is equal to the middle point 1. And so this is my relationship to find the middle. Now I could calculate a distance here, go 1 minus m and then find that distance over here. I could do all that calculation, but this is much easier to do because now I just solve for x. So x is equal to 2 minus m. So that's the coordinate of the point that's symmetrical. This coordinate is 2 minus m, comma, n. Right? That is now, I've now found the x position in terms of the variable m. For this one here, we want to find, this is again the same idea, is that we want to find, you just generalizing with lots of unknown variables. We have a point and we want to find the same point that's symmetrical. So the y coordinates are the same. So this coordinate that we're looking for is symmetrical to the one we're solving for. So what does this look like? We want to try to visualize this, and it's been generalized. So I'm just going to draw a random parabola. Okay, I'm going to have a point here at w and 8. Okay, we can put it on this side, we can put it on this side, doesn't really matter. It's some generalized coordinate. We're trying to find this coordinate here. We'll call it x and 8. And what do we know about this parabola? We know that this is just a, b, c. Okay, well, we know that that y coordinate must be c, wherever that is. Okay, what's the relationship we need to use to find this point here? Well, we need to use symmetry. Okay, this is why it's good to draw it out so that you can see what, to kind of start visualizing the math. Okay, so I'm just going to draw a little bit further to the right here so it looks a little bit more symmetrical. There's my line of symmetry. Okay, so well, that's great. We can find it physically on this random graph. What is important is what is the position of that line of symmetry? Well, that's going to be the p-value, which is negative b over 2a. Okay, so that is a line of symmetry. And so how do we find the x-coordinate here? Well, we did the same problem with numbers, so what's the difference? There is no difference. We know that the x-coordinate of that this point here, and the x-coordinate that we're trying to solve for, that we're trying to find, if we average out those x-coordinates, we end up in the middle, which is negative b over 2a. And I'm just solving for x. So I get w plus x is equal to negative b over a. I'm going to multiply both sides by 2. Solving for x, I get negative w minus b over a. And there it is. Now I could have drawn this, parabola anywhere I wanted. Could have drawn it upside down, doesn't matter. It still gives us the same relationship. And as generalization, we can say that negative w minus b over a will always locate the symmetrical point there.